All right, good morning, class. I know it's morning because you're watching in first hour. And today we are going to be talking about absolute value equations and how to solve them. So you've probably heard of absolute values back in middle school. And for the most part, the thing that we tend to remember really easily about absolute values is that they undo a negative, basically. So if I have an example of the absolute value of -10, we know that the answer to that, if I were going to evaluate it, I want to get a number answer, we would say that is equal to 10. So there are a couple of things about absolute values that I like to point out. The actual definition for absolute value is that it's a distance from zero. A distance, the number is from zero. So when I have something like the absolute value of -4, if I were on a number line and I had a point at -4, 1, 2, 3, 4, I would want to know what is this distance from -4 to 0. And that has a distance of 4. Distance is always a positive number. The negative often refers more to direction. So that's something that you can do to think about this. You can think about how the negative is direction, but a distance is always positive. And so if I gave you a different kind of number, like let's say I said, what's the absolute value of +3? Starting at 0, 1, 2, 3 is here. And the distance from 0 to 3 is still plain old 3. So the absolute value of 3 is 3. The distance that 3 is from 0 is 3. But see, what we're going to do now is in Algebra 1, we step it up and we make it equations. How do we actually deal with equations with absolute values? So if I started it off and said the absolute value of x is 4. Well, first of all, what we're saying is basically in question form, what number has a distance from 0 equal to 4? Anytime we see our variable, we read that in words, what number, because it's our unknown. Well, you're going to say, Mrs. Sullivan, we just did this example up here where we had the absolute value of -4 is equal to 4. And so you could say, well, I know that the number -4 has a distance from 0 equal to 4. So x can equal 4. And I'm going to say that's perfect. Yes, but it's not my only option. Because see, if I'm at 0, I can count for this direction in addition to for this direction. I can go both ways. So -4 on a number line works, but so does +4. So when we solve equations with absolute values, we have two answers. We have two numbers that we can plug into this x in my equation and get a true statement. So I have a process for how to do this, okay? Here's how to solve absolute value equations. I'm going to give it to you with an example that's a little bit harder. It's not very hard. The process is going to be the exact same. Let's say I gave you something like this. X plus 4 in absolute values is equal to 6. If we want to think undo, I say that we undo absolute values, absolute value bars, by writing two equations. That's key. We undo absolute value bars by writing two equations. So if I'm thinking undo, like we've been thinking for solving equations, I'm going to write two equations. Here's where I'm going to put one of them, and here's where I'm going to put the other. Well, where do I get two equations? Here's how you do it. You take what's inside the absolute value, the x plus 4, and we set it equal to the positive number on the outside, and we set it equal to the negative of the number on the outside. When we write our two equations, that's when we drop the absolute value bars. So they're in my original right here, but when I write my two equations, then they go away. So we set what's on the inside of the absolute value bars equal to the positive and the negative of the number on the outside. And then we solve those two equations individually. So I'm going to come over here and solve this one all by itself. We're going to say, how do I get x by itself? Subtract 4 from both sides. So x equals 2. Then I come over to the other side and I get x by itself. So I'm going to subtract 4. X equals -6 and -4 is -10. These are my two solutions. And again, what that means is I should be able to take these two numbers, plug them in for x in the original equation. So x plus 4 equals 6. The absolute value of my new x plus 4 equals 6. And we say, okay, simplify on the inside. 2 plus 4 is 6. Is the absolute value of 6 equal to 6? Yes, it is. Okay, how about -10 plus 4? That's -6. Is the absolute value of -6 equal to 6? Yes, it is. So we take what's on the inside and we write two equations by setting it equal to the positive and the negative. It will work every single time, except here's an exception, meaning this one's going to have a special solution. If I were to give you an example like this, where I have the absolute value of 3x plus 1 is equal to -2. This one right here, this one is a no solution. And I know that it's no solution before I do any work. The reason that this becomes a no solution is because the number on the other side of an equal of the equal sign is negative. This number over here, if it's a negative number, then there is no solution. So this, again, comes back up to the definition of an absolute value. We are asking ourselves when we look at this equation, what number, when I take it times 3 and add 1 and take the absolute value of it, is equal to a -2? Well, remember how absolute value, this piece right here, absolute value is a distance from 0. So we can't have things that are distances from 0 equal to negative numbers. So we don't want negatives on the other side of the equal sign, opposite of the absolute value. But they can kind of trick us up a little bit, because take a look at this one. If I give you the absolute value of 3x minus 6 minus 9 outside of the absolute value, okay? Check this out. It's on the outside of the absolute value. And if I'm setting this equal to -3, I'm going to clue you in that just because I see a negative number right here, that's not telling me no solution right now. And the reason has to do with this -9 on the outside. See, if I have a no solution, that happens when my absolute value is all by itself on the other side of the equal sign. There's nothing else happening in front of it or behind it. That's when I have a negative number and it gives me a no solution. But see, this one has this -9. So the way that I tell people to do it is that before I write two equations, step number 1, who likes steps in algebra, tell me exactly what to do. Step number 1 is to isolate the absolute value. So isolate, that means we have to get rid of everything else that's on the outsides of the absolute value. So my trick to knowing what I need to get rid of before I write my two equations is circle or put a box right around the absolute value. Anything that's happening outside of that box has to be gotten rid of or undone. So here I need to undo this -9. How do I undo -9? Add 9. So now I have the absolute value of 3x minus 6 is equal to 6. Now I have a positive number. And so this is where I'm seeing at this step that I have solutions. I do have solutions. And so then this is where I do step number 2. I'm going to undo the absolute value bars by writing two equations. How do I write my two equations? I take what's inside the absolute value, keep it straight up as it is. See how there's a minus sign in here? Just so you know, the absolute value bars do not change this minus to a plus. That is crucial, super, super important. Absolute values do not change subtraction to addition. Okay. So we're going to take what's inside right as it is, 3x minus 6. We're going to write our two equations. We're going to set this equal to positive 6 and set it equal to negative 6. And now we solve each of these two equations individually. Okay, so when I'm looking at 3x minus 6 equals 6, what do I need to undo first? Add the 6. Good. 3x equals 12. And how do I get x by itself? Divide by 3. X equals 4. That's one of my answers, but I have another one. When I come over here, what do I undo first? the minus 6. And how do I undo minus 6? Plus 6. 3x equals 0. Am I allowed to have that? You sure can. How do I get x by itself now? Divide by 3. What is 0 divided by anything? 0. Also, plug it in your calculator. When you plug in 0 divided by 3 and hit enter, your calculator tells you 0. So there are my two answers. Now, sometimes, this is my last example, sometimes when I have stuff on the outside, like this one, I'm going to give you -2 times the absolute value of 5x minus 1 minus 3 equals -11. Can I say that this is a no solution right now? No, I cannot say that. And the reason why is because I have stuff on the outside of my absolute value bar. So I have to undo this and this first, and then see if I have a negative number. Now, when you read this, how would you read this out loud? We would say -2 times the absolute value of 5x minus 1 minus 3 equals -11. So I have a multiply happening with the -2, and I have a subtract with my 3. So when we are undoing, we still follow the same rules that we had before, where I undo any adding or subtracting first. Then I undo any multiply or divide. So the order here is very, very important. Okay, I'm going to rewrite my problem. I'm going to rewrite it. Now I've got a clear space to actually do it. Okay, so first we're going to undo the -3 because we're going to add 3. Okay, so -11 plus 3 is a -8. Then we're going to undo this multiply by -2. How do I undo multiply? Divide, and we're going to divide by the -2. Those -2's cancel, and I have the absolute value of 5x minus 1 equals +4. So do I have solutions or do I have no solutions? I have solutions, and I find them by doing what? Write two equations. I'm going to take what's on the inside, 5x minus 1. I'm going to set it equal to the positive and take 5x minus 1 and set it equal to the negative. Again, notice how the 5x minus 1 does not change. It's minus and minus, both of those things, both those times. And so now we solve. Undo the subtracting first by adding. Then undo the multiply by dividing. Over on the other equation, undo the subtract 1 by adding 1. Now, -4 plus 1 is -3. Sometimes our brains automatically think -5 because it's trying to make it match the other equation. Don't do that. Leave your answer -3/5, and you're done. You should not have answers in this step where one is the +1 and the other one is a -1, or +10 and a -10. You should not get that, okay? I cannot think of a way that the numbers would work out to give you the same number but opposite signs. So if you get that, more than likely right in this space, you've probably done this addition incorrectly because your brain just kind of made an assumption. Okay, that is your notes. We are going to do more practice with this in class. So please come to class ready to go. We will see you guys later.